Hi, this is Arvind here. Today I'm going to speak about Kubernetes and its advantages and a small demo on how to deploy a service on Kubernetes. So, what is Kubernetes? Kubernetes is a tool for managing your containerized workloads, and it is used by a lot of organizations to support their large scale deployments. So Kubernetes is built by Google and it was open source in 2014. It is an open source platform which is utilized for managing your containerized workloads. So what do you mean by a containerized workload? So if you see traditionally, organization used to run their applications on physical servers, and each application ran on a separate physical server. So this was not scalable, obviously. So then people try to run multiple applications on a single physical server, which cause certain applications to hog the resources, and the other applications running on the same physical server would underperform. So this was a disadvantage. So then we have virtualized deployment using virtual machines. In virtual machines, each application has its own virtual machine, which contains of an operating system and its dependent libraries and binaries, and the application itself running on this entire stack. So this a single physical server has a hypervisor which can host multiple virtual machines. So this allows for better utilization of the physical server, and as well as it provides better security for each application as they are isolated within their own virtual machine. And it also provides for better scalability, um, as well as reduces hardware costs and so on. So next, but the disadvantage here is each application has, or each virtual machine has its own operating system, which is which which causes a lot of space consumption. So with the and the deployment is slower. But with containers, the advantage is all of the containers share the operating system, so the deployments are faster and you can roll back easily. It also has certain other advantages like application monitoring of the using metrics, as well as cloud agnostic, where you can run on any of those cloud providers like AWS, GCP, Azure, and so on. It is also loosely coupled, which is the hallmark of microservices architecture, and it provides for better utilization, resource utilization, and better configuration, easier deployment, and it is an integral part of your CI/CD pipeline, where you can easily deploy and roll back changes as well. So, so Kubernetes features that come with Kubernetes are service discovery, load balancing, or storage orchestration, automated rollout and rollbacks, self-healing if a particular container goes down. Kubernetes will get another container up and running to replace it. So let us look at a small demo. In this demo, I'll be using Minikube. So Minikube is a so let me start it. So Minikube is a simple and a lightweight Kubernetes implementation, the API implementation of its API, which you can install on your laptop or desktop on any of the operating system like Linux, Mac, as well as on your Windows operating system. Um, so you need to specify a driver. In this case, I'm using KVM, but you can also specify VMware or VirtualBox or so on. So apart from Docker for Minikube, you obviously need Docker as well on your machine. So once the Kubernetes comes up, then we will look at how to uh, create a simple Spring Boot application which has a REST API endpoint, and how to deploy this service on that particular on this Minikube instance. Right. So now we see that the Minikube is running. So next we will create a simple Spring application. So I will use the scaffolding to create a simple Spring application. So for that you can specify, um, you can use the Spring CLI, Spring Boot CLIs, um, and it has commands to scaffold your application. So here I will specify actuator, web flux. So actuator is a dependency that will help the monitoring. Webflux is for reactive web services, as well as dev tools for hot reload of with which will provide services like you don't need to restart when you make changes to your classes. So it has created a demo.zip. Unzip this file and remove the zip. Now let us see the contents. So it has a help um, file, which is nothing but a readme. You have your executable, Maven executable for Linux, for Windows. This is your pom.xml. We have a demo application, which where will define our REST API, our application.properties, and a test unit test file as well. So let us look at the pom.xml. So this is using 2.3.1 release, and we have the actuator here, um, webflux, dev tools, test, and this has a dependency on the project reactor library, which defines the reactive REST endpoints. So here we see that we have the Spring Boot Maven plugin. So here we'll add configuration. So this configuration I'm specifying to inform my the Spring Boot plugin to use the following image name. Call it apps demo. Let us run it. Alright, it says that it's running. So let us test it. Alright, now we need to specify a single REST endpoint. So let us go to the specific. Alright, so this is my Spring application starter. So specify the REST controller dependency. Also add the specific Spring framework. So we need to specify web bind annotation. Web bind annotation. Alright. Let us specify the get endpoint. Make it public. Returns a string. Call it get hello. Return hello world. What else will it return? This is the quintessential start of all our programming journeys, right? So let us now run the application, right? So it's reported that it started at port 8080, right? It's the hello world is being returned. So we have a working Spring boot REST application. So let us kill this. Right, so okay, so now it is stopped. Now let us create a image, Docker image from this Spring Boot application. So in order to do that, we just specify Spring Boot and build image. So 2.3 Spring Boot onwards has this Maven and Gradle plugin, which you can use to scaffold and build your Docker image from a, and which will do the basic configuration which is required for running a Spring application on a container. So it will pull in some build packs and these build packs are basically configurations which have are templates rather which specify the base image dependency, as well as which jar and which is the target classes where it should be extracted and so on. So this is a template um, which is used for usually most of the normal Spring applications. It's sufficient. So now that the image has been built successfully and it's called as apps.demo, so let us look at it, right? So it says here that apps demo has been created and added. So we can also deploy it So let us right, it says it's running. Let us do a curl to verify. Okay, so let us run this as a background service, or a detached service rather. So now we can do localhost and 8082 to verify if it's running. So in order to do this, let us actually check if the image exists here, right? So now, so the issue here is why it's not picking up the particular IP is because it is running on my Minikube daemon. So Minikube also has a Docker daemon running, and I have linked that daemon to my current Docker running on this terminal. So if I want to actually run it separately, let me open a separate terminal here. So here we can specify. So for this I can create a separate terminal. Me So here let me check. Right. So now if I so let me go to the projects and do a push the image again, spring boot build image. So when you run that eval command, what it does is it will set your Docker host and other parameters here. So if you see, so it sets it to this particular IP which points to my the Docker daemon running on Minikube. So that is the reason why not able to deploy this image onto a container. But let us try it on this terminal. So it is again pulling the specific build packs. So I guess this is the one of the disadvantage if you don't utilize your if you don't create your own Docker file. So it will each time it will fetch this build packs, and then it will based on that build pack template it will create and scaffold our Docker image. But if you already if you create a Docker file, then it should not require you to fetch this particular build pack. So while this is being built, um, I will show now that how to create a particular deployment. So to create a deployment, you need to so each when you want to deploy a particular service on Kubernetes, you need to specify a deployment.yaml. So a deployment.yaml is nothing but a REST object which which you give to the Kubernetes API server, and this will read the contents of the REST object, and it will create a service or a deployment as defined. So for that we will use the kubectl create command to create the deployment. So here I'm specifying create a deployment called demo using the image apps demo, specifying a dry run. That means it will not actually create it and it just output to a YAML file. Let's check the deployment.yaml file. So this is of kind deployment. It has the metadata called apps and label. So within the spec you specify the selector, which is app demo. So any request that comes in will be forwarded to all the pods that have this particular matching app.demo, this deployment, and is specifying the container as apps demo. So here we need to also specify image pull policy as never. So this is required because we are using the Docker daemon of Minikube. Let's check. Okay, the build is successful. So Docker images, it shows apps.demo. It shows it right. So now we can run. Right, it says it's yeah, it is running. Call local host 8080. Yes, it's working. So we have our Docker image. So now let us stop it. Docker so here we specify the name. So now it has stopped running as well. So now that we have a proper image, we can get back to creating our Docker our deployment.yaml. So next step is to to create a separator. So if you see it just adds a new line to it at the end after status. Next we have to create the service. So here I'm specifying the create service command of type node port. So there are different services that you can create. The default is the cluster IP that says that a particular service is available only within a cluster. Node port means it can be accessible from outside the cluster as well. And here the name is demo. You have specified the port 8080. So it's a dry run and it appends to this deployment.yaml. So if you see the deployment.yaml, it has added this service. Now let's check if there are any services running. So right now there's only Kubernetes running, which is the default API service that is running. So now we will um, also create the demo. So if you see get service, it has added the demo of type node port service, which is a cluster IP given as 10.104.86 and 2 and running on a port. This is a randomly generated port. So this is on what it's exposed externally. Internally it's the Spring Boot application running on 8080. So now we need to determine the endpoint to access. So the endpoint here is 192.168.39.77. So let us call this particular IP with the particular port 31191 that is specified here. So we see that the hello world is running. We can also have a look at the specific dashboard as well. I will show the dashboard here. So to check the dashboard you need to specify minikube dashboard, which will open it, as here. So it has a single deployment called demo, single pod, which is a single replica set, and this is the service demo.service running at this endpoint. So this is all I have to show for today's session. Thank you, and I hope to give some more sessions. Thanks.